Okay, so my last video got a little cut off at the very end because I ran out of battery, but I basically got what I needed to say out of it. The last thing I want to say is that if you're doing a cube from centimeters cubed to meters cubed, you have to move it 6 places, 2 per dimension, 2 places per dimension. Okay, so what I want to do, I think this is going to be my last chapter 1 video, and what we're going to do is we're going to calculate the density of a cylinder that I got. And so I just cut a piece of round wood, and we're going to measure the volume of that cylinder. Okay, so volume of a cylinder is going to be the area of the base. Now the area of the base is a circle, so the area of a circle is going to be pi r squared, and then we're going to have the height, which is height. So we're going to have pi r squared times the height. Okay, so first thing I want to do is I want to just kind of measure out as best as I can. Again, there's error and there's better ways to measure the diameter, but okay, right now we're measuring the diameter, and I'm going to measure that diameter to be about, I'm going to call it 2.85, I'm going to call it 2.9 centimeters. So I'm going to say diameter equals 2.9 centimeters plus or minus 0.1 centimeters. Okay, now we're going to need the height, or in this case the length. So we're going to go like this and like this, and I'm not going to draw a line between those two for you because that's going to mess up. Right now I'm in inches. That's not how I want to be. I always want to measure in centimeters or meters, etc., etc. So I'm going to say my height is going to be 23.4. I'm going to say it is 23.4 centimeters. So my height is 23.4 centimeters. Okay, so now the next thing is I don't want diameter, I want radius. Well, we know that the radius is 1/2 of the diameter. Okay, so we're going to say that my diameter, we're going to say that my radius is 2.9 centimeters divided by 2, so we're going to get 1.45 centimeters. Okay, now to find the volume I plug it all in. I say pi 1.45 cm squared times 23.4 cm. Pull this in here like this, on, clear. We're going to get pi. Where do I find the pi button? The pi button is right there, so I gotta go second pi times 1.45 squared times 23.4. Now here's what I want you to do with these calculators, is always just put everything on one line if at all possible. It makes it so much easier for me to check your work later. Okay, so we're going to say that the volume is 154.56164662 centimeters cubed. But that's ridiculous. Having all those digits is ridiculous. We do not just blindly copy down what the calculator has to say. I'm going to say that we really have at most 3 significant digits. So I'm going to say that my volume is 3 significant digits. So 1, 2, 3. But I have to look to the 4th digit to round. So we're going to round that up. So we're going to say that the volume is 155 centimeters cubed. But of course, the next thing we're going to do is we're going to convert that into meters cubed. So, just like I was saying at the beginning, we're going to say 155, and centimeters to meters is 2 decimal places. Cubed is 2 times 2 times 2 plus 2 plus 2, so it's going to be 6 decimal places. So we're going to go times 10 to the negative 6 meters cubed. Now we have to put it into proper scientific notation. Proper scientific notation says that it should be 1.55 times 10 to the, okay, now we made this number smaller by 2 decimal places, so that means we have to make this larger by 2 decimal places. Well, when we have a negative exponent that we're making larger by 2 decimal places, that means larger means add 2. So negative 6 plus 2 is negative 4. So we're going to say that the volume of my cylinder is either 155 centimeters cubed, or it is 100 or 1.55 times 10 to the negative 4th meters cubed. Now, I want to do density. Density is mass divided by volume. Or we're going to say rho equals m over v. That is not a P, that is a Greek R, and so that is a Greek rho. Greek rho. Put that up so you can see it like that. Okay, so I need to know the mass of my cylinder. Well, it just so happens that right here I have a little thing that's going to let me weigh it. And now what's a little bit strange, hang on, it's just got to not roll off. Okay, so I don't know if you can see, you got some glare on there. I don't know how I want to put the glare. There we go. Okay, so it says 99 grams. 99 grams. Okay, so I'm going to express 2 things. I'm going to say up here my mass is 99 grams, or it's going to be 0.099 kilograms. So my density is either going to be 99 grams divided by 155 centimeters cubed, or it is going to be 0.099 kilograms divided by 1.55 times 10 to the negative 4th meters cubed. Okay, so that's going to give me 99 divided by 155. That's going to give me, I'll write that down in a second, 0.099 divided by 1.55, second EE, negative 4. That gives me 638.7. Doing 3 significant digits. Probably, let's go a little bit more than that. We're going to say 0.64. The density is going to be 0.64 grams per centimeter cubed, or we can call it 640 kilograms per meter cubed. Okay, and in the last 7 seconds, all I want to say is that The density of water is 1 gram per centimeter cubed. This is less than that, and so that means that it will float.